Advanced Higher Chemists, this one is for you. Let's go over this equilibrium constant question from the 2025 SQA Advanced Higher Chemistry exam. So in the question, they're doing a solvent extraction of caffeine in order to determine the equilibrium constant. So they've said that 100 centimeters cubed of aqueous caffeine solution containing 0.150 grams of caffeine was mixed with an equal volume of dichloromethane, and then the mass of caffeine in the dichloromethane was found to be 0.136 grams. Then you're asked to calculate the value of the equilibrium constant for this extraction. So anytime you're asked a question to do with equilibrium constants, you need to write your equilibrium expression. So that's always K equals to the concentration of the products, which in this case is the caffeine in the dichloromethane. I'm just going to abbreviate this for the sake of time, over the concentration of the reactants, which in this case is the caffeine in the aqueous solution. Once you've got your equilibrium expression, you then need to work out what the concentrations at equilibrium were. So the question's already told us that they found the mass of caffeine after the extraction in the dichloromethane layer to be 0.136 grams. So that means we know the mass of that was 0.136. We now have to work out then how much caffeine was left in the aqueous layer at equilibrium. Now we know that the amount of caffeine there was originally was 0.15 grams, so it should make sense that then what's left in the aqueous layer is the 0.150 grams, take away the amount that's now moved into the dichloromethane layer. If you put that in your calculator, that should give you 0.014 grams. So now we've got the quantities of caffeine in the dichloromethane layer and in the aqueous layer at equilibrium. We can plug these into our expression. I decided to change the colour on these so we don't mix them up, and it's colour coded. So the mass of caffeine in the dichloromethane layer at equilibrium is 0.136, and the mass of caffeine in the aqueous layer at equilibrium we worked out to be the 0.014. All we need to do now is put that into our calculator, and that should give you a value of 9.71428, whatever, but you can just round to 3 or 4 significant figures. And don't forget, equilibrium constants never have units, because as you can see here in the division, both of those grams would cancel out with each other.